Okay, in this video tutorial I'm going to teach you a little bit about double bonds. So what is a double bond? You might think it's just two bonds. Well, it kind of is. It's two bonds between the same atom. So let's talk quickly about, just refresh our memories, what would we mean if we spoke about a single bond? Well, so far the bonds we've looked at or we've spoken about are single covalent bonds, and we've often drawn them. So for instance, a carbon atom bonded to a hydrogen atom, or we could draw methane again. So methane, our simplest alkane, a carbon surrounded by four hydrogens, and at each of these points where I've drawn a line, the carbon atom is actually sharing a pair of electrons. So let's actually draw in those electrons. Just grab a different color. So let's say carbon has 4 electrons. And to get a full outer shell, it will share electrons with hydrogen, and each hydrogen has 1 electron in its outer shell. So carbon has 4 valence or outer shell electrons. Hydrogen each has 1 valence electron. So it shares those electrons to have a full outer shell. The hydrogens now have a full outer shell, and so does carbon. So each of those is drawn as a line representing a single bond. So what happens if you've got an atom who needs a few extra electrons? So for instance, one of the examples we'll look at is that oxygen can bond together with another oxygen to make oxygen molecules, O2 molecules. But each oxygen only has 6 electrons. So let's draw those in. We've got oxygen 1, draw 2 on the top, 3, 4, 5, 6. And if we draw another oxygen, 1, 2, 3, 4, 5, 6. So if they share 2 in the middle here, that's all great. We've got a single bond here, but they still don't have a full outer shell. So in order to gain a full outer shell, they actually need to share another pair of electrons. So essentially, if 2 atoms are bonding or sharing electrons to try and gain a full outer shell, but they can't achieve a full outer shell by sharing a single pair of electrons, what they'll actually do is share another pair of electrons. So these single electrons here that are still left over kind of go into the middle here, and if we share 4 in the middle, so get rid of those. If we share 4 in the middle here, each atom now has a full outer shell. So this oxygen has 8, and this oxygen has 8. So what we can draw this as an oxygen molecule that is double bonded to another oxygen molecule, and they've each got 4 valence electrons left around there. So we've actually got 4 electrons, 2 pairs of electrons being shared here, and that's how they get their full 8 electrons. So let's have a look. So the answer is essentially this: if 2 atoms don't have enough electrons to get a full outer shell, they simply need to just share more, and that's how we get a double bond. So let's look at a few examples. Double bonds: a chemical bond in which 4 electrons are shared, as opposed to the usual 2. So oxygen has an electron configuration of 2, 6. It has 8 electrons. You know that from the atomic number. 2 in the first shell, 6 in the next. So as I said, alright, the electrons in oxygen can't be shared like this. So what's wrong with these? What's wrong with this one? Well, each oxygen has 6 electrons. This one has 2 electrons just added, magically appeared. So we can't just add extra electrons from nowhere. So this one here is definitely wrong, because you've got extra electrons that have just appeared out of nowhere. Or we've got another option here. Well, here, yep, they're sharing one pair of electrons here, but the oxygens still don't have a full outer shell. So atoms will only share electrons in order to gain a full outer shell. So this isn't going to cut the mustard either. It's not quite right either. So the thing that was wrong with this, we can't just add electrons out of nowhere. And the thing that's wrong with this, the thing that's wrong with that one is they still don't have a full outer shell. So this is how basically, so here we go, too many electrons, they don't have that octet, that full outer shell. And this is the answer. So one oxygen shares 2 electrons, and the other one shares 2 of its electrons, so we get 4 electrons being shared here in the atom. And you can see down in the bottom corner here, that's an alternative way of drawing it. So remember, a single bond is a pair of electrons being shared, and a double bond here is just 4 electrons being shared, so that this oxygen atom now has 8 valence electrons, 2 here, and 4 in the middle. We can count those as being in its outer shell. And this one also has 8 valence electrons. So it's worth noting you can, I guess generally they're drawn like this. You can draw all 4 in a straight line down the middle. This is probably more generally the accepted method, but I have seen the other one too. Now you may notice this one's been drawn with crosses. So for a Lewis, this is a Lewis structure, what we've drawn. When drawing a Lewis structure, sometimes people draw them as dots and crosses, just to show which atom has contributed which electrons. So these electrons have come from this oxygen, and the crosses here are electrons that have come from this oxygen. You could, often people will draw them all just as dots, and that's just a preference thing again. So there's the Lewis structure for oxygen. So let's look at a couple of other examples. Ethylene, CH2CH2. So if we go to draw that normally, we've got a C. Sorry, giving away the answer there. So we've got a C, and remember that the non-carbon atom is bonded to the next non-carbon atom. And each of those has a hydrogen, 2 hydrogens, sorry. So we've got a molecule that looks like this. But carbon has 4 valence electrons. It's going to want to form 4 bonds. So the fourth one is, rather than having can't bond with nothing, rather than having lines coming down there, what will happen is we'll have a double bond here. So to show you the Lewis structure again, for ethylene, or ethene, here is 2 carbons sharing 4 electrons, that double bond there, and a single pair, a single bond with the hydrogens. Carbon dioxide, similarly, you've got a carbon atom in the middle with 2 oxygens either side. Maybe we'll do that one ourselves just to go through it. So I know carbon here in the middle. Carbon normally has 4 valence electrons. Oxygen has 6 valence electrons. So I draw an oxygen on this side too. 1, 2, 3, 4, 5, 6. Sorry, making a little bit of a mess there. So you can see none of them actually have a full outer shell yet. So what actually needs to happen is oxygen needs to throw in an extra one, and it's only going to do that if carbon also throws in an extra electron. So we can get rid of these, the bottom ones, and put those in the middle, being shared in between them again. And on the other side, so this oxygen is now happy, it's got 8, but now this carbon and this oxygen need to do the same thing, throw in that extra electron, so that they now have 4 electrons, 2 pairs of electrons in the middle as well. So now everyone's happy. Carbon's actually got 8, 4 on that side being shared there, and 4 on that side being shared, and the oxygens have 8 too. So that's the answer that we popped up just before here. So carbon, you can see, normally has 4 valence electrons. You can see 2 of them here and 2 of them here, and oxygen has 6, 2 here, 2 here, 2 there, and this oxygen also has 6. But you can see that when they're sharing 2 pairs here and 2 pairs here, it gives all 3 atoms a full outer shell and makes it a stable molecule. Another way of drawing it, so just again, as I said, with dots and crosses, you could show here carbon could be the crosses here. Those are the 4 valence electrons from carbon, and as I said, they can be put in a straight line, and the dots representing electrons from the oxygen atoms is just an alternative way of drawing it. This is probably the more commonly accepted one, but both of them are actually valid representations. So, what do you do if you've got if you have a double bond and that's still not enough electrons to form an outer shell? Well, the answer, just as before, is again to share even more. So a triple bond, and this is going a bit further, you probably don't need to know about these, but a triple bond is a bond in which 6 electrons are shared, as opposed to the usual 2. So for instance, ethine, otherwise known as acetylene, is actually a triple bond here, C triple bonded with a carbon. So let's do the Lewis structure for that, just to show you again how we get that. So carbon has 4 valence electrons, and we know it's got 1 hydrogen on it, so that hydrogen is going to contribute 1 electron there. And we've got another carbon, and that has 4 valence electrons, and it's sharing with 1 hydrogen on this side too. So triple bond here, what that means, well, carbon, the hydrogen has a full outer shell. They've got 2 electrons, which is a full outer shell for hydrogen, but carbon definitely doesn't. So if it puts an extra electron, puts these top ones in, if each carbon contributes another pair, so we get rid of the top ones here, and they go into the shared pool here in the middle. Carbon still doesn't have a full outer shell, so this carbon's got 4 here and 2 here, but only 1 there, still 7. So what do? They just share another pair. So the bottom pair of electrons here, they get shared into the middle as well. So they get put, and maybe this time I'll put them just like that. So you can see here the triple bond sharing 1 pair, 2 pair, 3 pair of electrons. So carbon now has, this carbon has 6 electrons on this side and 8 electrons around it. They've got a full outer shell. So a slightly tidier version of that. We'll bring up the answer. There you go. A triple bond, so drawn as 3 lines or 3 pairs of electrons. And as I said, they can be drawn straight up and down, or they can be drawn like that, but just showing that sharing of electrons in the middle. So that's a triple bond. Now you probably really only need to be familiar with the double bonds, but the triple bond, it's basically the same principle. So I'll just go back up to the double bond. So here, basically, if there aren't enough electrons to form a full outer shell, then basically the spare electrons on the carbon can also be shared in the middle. So they're already sharing electrons to try and get a full outer shell. They can just share another pair to ensure that they get a full outer shell. So that's essentially the story of double bonds. I hope you found that helpful.